Now we will take one problem based on this law, wherein we will be finding out the magnitude of the magnetic field and also direction. Take down this problem. A wire of length L is bent round in the form of a coil having n turns of same radius. If a steady current I flows through it in clockwise direction, if a steady current I flows through it in clockwise direction, find the magnitude and direction of the magnetic field produced at its center. Now let us read it once again. A wire of length L is bent round in the form of a circular coil having n turns of same radius. A circular coil and has n turns of same radius. If a steady current I flows through it in clockwise direction, we have n turns, remember. Steady current I flows through it in clockwise direction. Find the magnitude and direction of the magnetic field produced at its center. We know now we have already learned what is the magnitude of the magnetic field at the center of a circular loop carrying clockwise current, or also we know what happens if the current is in the anti-clockwise direction. Now the same thing we can apply for this condition. We know that the magnetic field at the center of a circular loop of radius r and carrying current. We know that the magnetic field at the center of a circular loop of radius r and carrying current I is given by, we know that the magnetic field at the center of a circular loop of radius r and carrying current I is given by B is equal to mu naught into I by 2r. Mu naught into I divided by 2r. Now if there are n turns, then it will this B will be multiplied by n, mu naught into I by 2r. For n turns, for coil with the n turns, or for a circular loop with n turns, B becomes equal to, this equation have to be multiplied by n. Mu naught into Ni, that is the total current then, divided by 2r. Now here I is the current and N is the number of turns. Now we know the length of the wire, so let us try to write in this equation in terms of L, because here R is not given. Now you can write a small note over here. When a straight wire is bent in the form of a circular coil of N turns, then what happens? The length of the wire will be equal to the circumference of the coil multiplied by number of turns. When a straight wire is bent in the form of a circular coil of N turns, then the length of the wire is equal to length of the wire is equal to circumference of the coil. Circumference of the coil multiplied by the number of turns. So total length N is made into N turns, and coil with you can take the radius of the coil as small r. Circumference of the coil multiplied by the number of turns. Circumference of the coil multiplied by the number of turns. When a straight wire is bent in the form of a circular coil of N turns, then the length of the wire is equal to the circumference of the coil multiplied by the number of turns. Given L is the length of the wire. Given L is the length of the wire. Now let us say, let R is the radius of the coil. Therefore, now length of the wire is N into circumference of the coil according to this note. Therefore, length of the wire capital L is equal to N times the circumference of the coil, because the coil has N turns and the total length is L. Circumference the coil. Now therefore L is N into circumference is 2 pi r. Therefore R will become equal to L divided by 2 pi n. Why we found this means we need to calculate the radius r in terms of the length, because in the given problem we don't have the radius, we have only the length of the wire. Whatever equation we have here, mu naught Ni by 2r, the r is coming, so replace this r by the given term, that is the length of the wire. Therefore the magnetic field now becomes equal to field at the center B is equal to, we know it is mu naught Ni Ni divided by 2r. Replace r by L divided by 2 pi n. What do we get? R is L divided by 2 pi n. Simplify this, we get mu naught, the 2 will cancel, pi mu naught pi n square into I by L, because this 2 will get cancelled with this, and all this pi n goes to the numerator. Therefore mu naught pi n square into I by L. The magnitude of the magnetic field is B is equal to mu naught pi n square into I by L. Now we also have to write the direction. Here the current is clockwise. Now if you apply the right hand grip rule, you will get the direction perpendicular to the plane of the loop and entering into it, or it is going into the plane of the paper, or the direction is inward because the current is clockwise direction. I can show you here. Now we have clockwise current, therefore direction is going into the plane. B, the direction of magnetic field is perpendicular to the plane of the loop and entering into it, or I can say it is inward if the current is flowing in the clockwise direction. That is why here it is cross, represented by cross.